Good morning, we are the Ecosystem team from the Guadalupe campus, and today we are presenting our proposal for the challenge evolution of CAFFENIO's drive-thru ordering ecosystem. We have identified an opportunity to improve the service, mainly in terms of waiting times and organization during the peak hours. Our proposal seeks to make the process faster, more orderly, and more convenient for the customer, using digital tools that help both the user and the work team. Below, I will introduce the member of the Ecosync team: Stephanie Maite Carvajal Yáñez, Gerson Rodrigo Gómez Ramírez, Carol Paulina Guajardo Garcia, Walter Daniel Vázquez Vázquez, and myself, Evelyn Sofia Ramos Sainz. We are all MAPS professional semester students at Guadalupe campus.
The drive-to lane and waiting line. Once they reach the screen, they stop their vehicle and begin browsing the menu display. After selecting their products, they can use the touchscreen to add items to their order. Then, the total is reviewed and confirmed. The customer moves forward to pay, and finally, to receive their food or beverage. Now, even though this process works, we identify several important problems. The first issue is excessive ordering time. Customers often take longer to browse the menu on the screen, which create longer lines and reduce overall service efficiency. The second problem is overheating of the tablets. When the system overheats, performance becomes lower, malfunctions may occur, and there is a risk of long-term equipment damage. The third issue is the fragility of the equipment and its supports. Weak or poorly reinforced metal structures increase the risk of damage from accidental vehicle impacts, as well as wear caused by weather conditions. Because of these challenges, we establish a clear objective. Our main goal is to improve the efficiency, durability, and operational performance of the CAFFENIO drive-thru ordering system. This will help reduce waiting times and prevent equipment failures. To achieve this, we define three specific objectives. First, reduce customer ordering time by improving menu visibility before customers reach the tablet. Second, prevent tablet overheating by implementing better ventilation or cooling solutions. And third, strengthen the metal support structure to increase resistance and durability against impacts and environmental conditions. User experience and ordering screen interface design. Primary user, drive-thru customer, a driver in a hurry. Secondary users, passengers, and store staff. Interaction flow. Customer enters the queue, sees the menu along the lane, decides before reaching the screen, stops at ordering tablet, selects and confirms order, moves to payment and pickup. Information organization decisions. Large menu panels before the screen, clear categories, drink, food, combos, ordering summary always visible. Accessibility considerations. Large buttons and high contrast, anti-glare skins, simple language and icons.
Now, let's see the physical design, protection, and screen durability. We have 4 key components. They are the outdoor touchscreen, a special screen that's water resistant and pretty strong. The reinforced metal structure, which we remaked with a new modern design, and what we think is the perfect design for drivers to interact with the screen. Then we have the ventilation system, one of the most important things in our proposal, because we're trying hard to fight the overheating problems in our drive-thru system. And the protective glass, a tempered glass panel that goes in front of the screen, this to try to protect it from vandalism and possible external dangers to the screen. Now, talking a little bit more about protection solutions, we have an IP66 sealed casing, which means that our metal structure is completely dust and water resistant. We also have tempered glass panel that I mentioned before, and finally, we also considered as a protection solution our internal airflow ventilation system. As I said, our cooling system is nothing but ventilation openings included in the casing, but what actually helps us with overheating is the type of components we used in the casing, given that there is nothing but a screen and a signal receiver for make the screen look more fluent. And these components that don't emit a lot of heat. And in addition to this, we have the sunshade cover all over the line. And about the ergonomics, our totem is 1.40 meters tall, which we think is the perfect height for all type of cars, sedans, SUVs, and pickup trucks. We also put the screen with a 15 or 20 degree inclination to avoid the sun reflection, and we implemented a pre-menu with our best sellers on it so the driver can see them while being in the line. Now, Getting into financial proposal and cost efficiency, we had an estimated investment with a maximum of 50,000 Mexican pesos, and our final investment was of 45,944 Mexican pesos. Our main components was the industrial touch monitor, the reinforced metal structure, the ventilation system, and the tempered glass protection. We considered an alternative for our industrial touch monitor. We chose the option A, the high brightness monitor of 1000 nits. It can be a little expensive but works better in worst conditions, and that is our priority. The option B was the ELO Touch Open Frame Series 90. It is cheaper and the touch system is slightly better, but overheats a lot and it needs to be replaced constantly. Now about the cost and benefits, our high brightness monitor requires fewer replacements, lower maintenance costs, reduced downtime, faster service, and offers less overheat. And now, one of the most important points in our proposal is the performance indicators, measurement, and alignment with success metrics. We're going to have 3 key indicators. The first one is the average order time that we're going to measure with the help of the system time loss, and our target is to reduce it at least by 25%. The second one is the screen overheating incidents that we're going to measure with the maintenance reports, and our target is to get it to 0 overheating failures. The third one is the equipment damage report that we're going to measure with the help of the monthly performance review, and our target is to reduce it at least by 50%.
Implementation plan and replication process. Phase 1, pilot, 1 month. Install in one store, measure order time and screen temperature. Phase 2, adjustment, 2 or 3 weeks. Improve ventilation and structure if needed. Phase 3, scaling, 2 or 4 months. Install in multiple high-traffic stores. Replication strategy. Adapt structure to hold climbs. Adjust layout for urban or suburbs stores. Standard installation manual. Risk and technical operation feasibility. First risk is ventilation system fail. Overheating may continue. Mitigation, preventive maintenance and temperature sensor. Second risk, structural impact from vehicles. Damage to equipment. Mitigation, reinforced steel frame and protective barriers. 3 risk, customer resistance to change. Risk, users ignore menu panels. Mitigation, clear visual design and promotional signature. Operational compatibility. Or propose don't need to change the current ordering process or change the tablets on the system software. Only need a physical layout improvement, and it will be easy integration into existing CAFFENIO drive-thru operations. Use of artificial intelligence. How AI was used. Text improvement to refine wording and make the proposal clear, formal, and professional. Imagine creation to generate visual concepts, mock-ups of the improvement drive-thru system, and the prototype. Purpose of AI use. Artificial intelligence was used as a support tool to improve the clarity, visualization, and design efficiency during the development of the proposal. It supported the creative and technical process, but the final decisions were made by our team.
To conclude, our proposal improves the drive-thru system in 3 ways. Menu preview along the line, protected and ventilated screens, and a stronger metal structure. This change reduces order time, decreases equipment problems, and improves durability and customer experience. This proposal is cost-effective, easy to implement, and can be used in different stores. In summary, it improves efficiency, reliability, and customer satisfaction. Thank you.